In this lesson, we're going to be talking about prime and composite numbers and prime factorization. They kind of go together. Just like we have odd and even numbers, we also have prime and composite numbers, where a prime number only has two factors, one and itself. Composite factors have more than two factors. So let's, for example, look at 5. 5 is a prime number, and 5 is a prime number because it can only be made up with multiplying 5 times 1. Because remember, a factor is a whole number that goes into another number. So if we look at 7, 7 is 7 times 1. And 29, for example, the only way I can make that is 29 times 1. So these are all prime numbers because 5, 7, and 29 only have two factors, one and itself. Okay, composite has more than two factors. So let's look at 10. 10 can be 10 times 1, and 10 can also be 2 times 5. So 10 has four factors, 10, 1, 2, and 5. So more than two factors. If we look at the number 16, 16 is 16 times 1, 2 times 8, and 4 times 4. Okay, so this again has more than two factors, and actually 16 has five factors. 16, 1, 2, 8, and 4. So composite numbers, more than two. Prime numbers, only two, which is 1 and itself. Now that we know what a prime and a composite number is, we can do prime factorization. What is prime factorization? It's when we take a number, an expression, and we break it down to only when we have prime numbers that are factors of that number that are being multiplied together. So let's take 20, okay? 20 can be multiplied several ways, okay? We can do 20 times 1, 2 times 10, 5 times 4. But I only want them to be prime numbers, and 10 and 4 are not prime numbers. So we need to break it completely down in order to get prime factorization. And we can do this two ways. One was with a factor tree, and the other way is what we call the slide method or the cake method. So I'm going to do the tree first, and then I'm going to do the slide method. And again, you can do whichever method that you prefer. I prefer the slide method because it will help us later on with greatest common factor and least common multiple. So if I take 20 and I start breaking it apart into my multiplication problems, we want prime numbers. And 1 is not a prime number, so I wouldn't write 20 times 1 down on here. I would break it apart to 2 times 10 or 4 times 5. I'm going to go ahead and do 4 times 5. And I circle my prime number. And my prime number in this case is 5. And then I keep breaking 4 because 4 is a composite number. We keep breaking that apart into prime numbers. And 4 is 2 times 2. And 2 is my only even prime number. So I'm going to go ahead and circle that. So 20 is 2 times 2 times 5. All three of these numbers are prime, and they're all multiplied together to get my composite number of 20, because 2 times 2 is 4, and 4 times 5 is 20. Now, if I use the slide method or the cake method, I put 20 in a division box, and again, I start with prime numbers. So I'll start with 2 first. 2 goes into 20 10 times. This looks like long division, but since it goes in evenly, I don't write anything below. 10 is a composite number, so I keep going. So 2 also goes into 10 5 times, and 5 is now a prime number. And look, I have the 2 times 2 times 5. 2 times 2 times 5. So these are my numbers that would make up my prime factorization. Okay. All right, let's look at 36. 36 is a composite number. It's an even number, so I know it's composite first of all because I know 2 will go into it. So we're going to start off with the tree first. So if we go 36, I know that 36 is 6 times 6. So I'm going to go ahead and write both of those 6's down. Some of you would like to do 2 times 18. Others of you might want to do 4 times 9. Any of those options are correct. So if I go 6 times 6, 6 is a composite number. So I keep going down to 2 times 3. Notice there are no ones allowed in my trees. I'm only looking for prime numbers and 1 is not prime. So I'm left over with 2 times 3 times 2 times 3. So I can rewrite this as 2 times 2 times 3 times 3. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. Okay, so again, I can use the cake method if you would like to. 36. Again, I need to start with a prime number. That's the only thing with the cake method is I always have to start with a prime number. So I know it's even. So I'm going to start off with 2. 2 goes into 36 18 times. 18 is composite, so I keep going. 2 goes into 18 9 times. 9 is a composite number because I can do 3 times 3. And 3 is a prime number because the only way I can make 3 is 3 times 1. So I'm done. And again, there's my 2 times 2 times 3 times 3 that I have written down here at the bottom. Another reason that I like this slide method or the cake method is a lot of times 6th graders will write 18 times 18. They'll just break this into 2 equal pieces instead of writing 2 times 18. Or for 20, they'll write 10 and 10. So that's the other reason why I like the cake or the slide method much preferably over the tree. But if you are more comfortable with the tree method, then please by all means use that way as well.